Hello guys, welcome back to Maison African Motives, still on A-level mathematics. In this platform, we shall be focusing on quadratic inequalities, which is one of the most important parts that we are supposed to know. Its basic presentation, because you can have the applications of inequalities later on, but just for the meantime to know how to solve quadratic inequalities. So take note, we are referring to quadratic from our quadratic equations. We had this part where we know that our quadratic equation was given in the form of ax squared plus bx plus c. From our O-level mathematics, it was equal to 0. That was an equation. So if it is now an inequality, we are now either saying this is not equal to 0 actually, okay? So it's no longer equal to 0. So it can be greater than 0, it can be less than 0, it can be greater than or equal to 0, it can be less than or equal to 0. It's now an inequality. So whenever you are solving inequalities, what you need is to first find the critical values by solving a normal quadratic equation, okay? So we are going to find the critical values. The critical values, which is by solving a normal equation, by solving a normal equation. Not an inequality, but you are now taking it as an equation. You find the critical value. The critical values are the values of x, like to say x is equal to 3, x is equal to 4. These are the critical values. Okay, then after finding the critical values, you are going to apply, I don't know which part are you going to use. You are going to apply, either you're going to work with graphs or you're going to work with tables. I don't know which part are you going to apply to find the exact solution, or to find the required inequalities. Okay, to find the required inequalities. Okay, so what am I trying to say, guys? We are dealing with an inequality here, not an equation. You have the values of x, then you are going to apply the graphs, or some they can even apply the table. All right, sorry for that. So in this case, guys, we are just going to have one or two questions, then I'll explain what is important. Then the other things that we know, we can as well be revising and so forth. Okay, so we'll be given to find the range of values of x that's satisfied by, or to solve the inequality. So let's write the first question we are given to solve. X squared plus x minus 6 is less than 0. Okay. So like I said, the first thing is to find the critical values. These are the values of x that you're going to find by solving the equation that we have, the equation that you're going to formulate of x squared plus x minus 6 is equal. So you just to solve usually the way that you are used to, okay? Or the first thing that you can do is just factorize this part. We know that it's a quadratic from our quadratic equation, but maintaining the inequality sign, okay? So knowing that we can factorize here, do we have factors? Let's see. Focusing with -6, do we have factors of -6? That when we add, we are going to obtain a positive one. Remember from your factorization in mathematics for O-level. So we have got 3 and -2. If we multiply these two, as we can see, we obtain -6. If we add, that's a positive one. So these are the factors. So we are going to have x plus 3 here, x minus 2 here. So for the critical values, you are now writing not with the inequality, but you are writing the actual value of x that you are going to obtain from this equation, like x plus 3 into x minus 2 is equal to, like an equation like this. So we know that x is going to be equivalent to -3 or a +2. So that's x is equal to -3 or x is equal to +2. So take note, these are the critical values, the values of x that you obtained, not the solutions to the inequality. An inequality is here. We are supposed now to obtain the actual values. So it's either you're going to use a number line, you're going to use a table, you're going to use functions, graphs. I don't know which part you're going to use. But let's take this from the graphical method. to obtain the exact values from our graphical method, this is what is going to happen. You need to find or to sketch this graph, okay? You need to sketch the graph of f of x. So in this case, our f of x is this x squared plus x minus 6. This is your f of x. So our f of x is the one that is equal to x squared plus x minus 6. But we are given that this f of x that we are referring to as x squared plus x minus 6 is less than what? It's less than 0. So know that from your sketch is a quadratic graph. So if the coefficient of x is squared like this, from our equation f of x, which is ax squared plus bx plus c, if a is greater than 0 like this, is a positive, our graph is going to be a smiley shape. When positive, you're always smiling, isn't it? Okay, when a is less than 0, that's a negative, is going to be a sad shape like this. We are going to have it as a sad shape like that. So it's going to be a sad shape. Then it's going to be a smiley shape, okay? That's for positive, okay? When this is a positive, when it's a negative, it's always sad. So in this case, we are given a, it's a positive, so you're going to have a shape like this, okay? So this is what we are going to have as our shape. And the critical values, these are the solutions at -3 and at +2. So that means our graph at the end is going to be something of this nature. I want you to understand, guys. So this is your x, all right? And this is your y. So like I said, the graph is going to be a smiley shape crossing at -3 and crossing at 2. So this is our -3 and this is our 2. These are the critical values. So it's going to be like this, a smiley shape. All right, so this is your f of x. So now from our f of x, we are given that when it is less than, take note, we are given that our f of x, which is x squared plus x minus 6, it's less than 0. So where do we find the values which are less than 0? For f of x represents y, it's like y is equal to. So you're saying that y is less than 0. Where do we have our y less than 0? If we are to check, guys, above the line, above the x-axis, y is a positive. This is where we have 1, 2, 3. So which means y is positive above and y is negative above. So the solutions that we are going to have where our f of x is less than 0, where it is a negative, is going to be in between this region that is between -3 and 2 down or up or below the x-axis. Okay, so take note, your solutions, they are going to be below the x-axis. So taking below the x-axis, which means you're taking values in between -3 and between 2, in between these values, -3 and 2. So therefore, the values of x that you are going to have in this case are going to be, therefore, our x that we are going to have is such that our x is greater than, because we are talking about values in between -3 and 2. So they are greater than -3, but they are less than 2. So x is greater than -3, but less than 2. All right. Take note also on this part, guys. Take note on this consideration. If it was a condition that we are given here as greater than, or sorry, less than or equal to, let's say this was a less than or equal to here, your answers, you are going to indicate less than or equal to, also less than or equal to, you are going to represent like this, but we are not given that condition. So that means we do not indicate this less than or equal to, we just indicate less than, or we just indicate a greater than. Okay. Then the other thing that I want us to check is that let's say this inequality was for us to solve, it was like this. Let's say the question was for us to solve x squared plus x minus 6, but this time greater than 0. It's still the same way. Here it was less than. Now it's a greater than. So which means you're going to do the same thing. You find your critical, it's not going to change. You find the values of x like that, what you obtain. On the function now, on the actual values now, we are now going back to say it's greater than 0, which means our f of x is above 0. It's a positive. So where do we have our graph above the x-axis that is positive? It's above x-axis. We are going to see that the solutions are from this point here. At this point, these are the values above the x. We are going to take solutions from this point, and at this point. So what is the indication? What does this part mean? It means that your values of x are from -3, -4, -5, -6, up to infinite. We do not know where these values are going to end. Also, the other values of x are going to be from 2, direct at 2 here, from 2, 3, 4, up to infinite. But take note, it's greater than, so which means we are going to write these solutions as x is going to be, we said less than, was -3, -4, -5, -6, compared to -3. They are less than -3. Or our x is going to be from 2 here, 3, 4, 5, these values, they are greater than 2. So take note, and x being part of all the real numbers that we have. So take note, guys, here that x, if it was a function where it is greater than 0, these were going to be the solutions. But the same working, what I'm trying to say is that the critical values that we obtained, or the critical values that we obtained from this part, will remain the same. We are going to have the same critical values. The only thing that is now changing is where are we finding these values of x. All right, so that is the part that you're going to use if you are dealing with inequalities. So like I said, you can even use the table, okay, whereby maybe you can just use on another typical question, which is very, very easier to use a table like this question, where you'll be having rational fractions. Okay, let's say we are given a condition where we have got rational fractions. Okay, rational fractions, inequalities. If you are given a condition whereby you have got a fraction, let's say in this case, we have got x minus 2 over x minus 5 like this, which is less than a 3. All right, this is the question that you're given. Take note, for you to solve, these are the steps that you're going to take, okay? You have to bring all the functions on one side, never cross multiply. Take all the functions to one side of the inequality and never cross multiply. Okay, so that's the first thing that you're going to have, which means we can transpose the 3 to the left-hand side so that it can be a negative, never cross multiply. So that's x minus 2 over x minus 5, all right, over x minus 5 minus 3 is less than a 0. Okay, then from there, definitely you have to take the LCM and simplify on fractions. That is, you have to subtract or to add. So in this case, this is same as over 1. So remember, if you're adding fractions, you have to find the LCM of x minus 5 and 1, which is x minus 5. So let's subtract x minus 5 divided by x minus 5. That's 1. And 1 is going to multiply x minus 2. Then we've got minus x minus 5 divided by 1. That's x minus 5. Then we multiply by a negative 3. So it's negative 3 times x minus 5 less than a 0. Okay. So let's see what you're going to have here. That means we can multiply 1 and x, which is x minus 2, minus 3 times x, minus 3x, minus 3 times 5, that's a positive 15, all over x minus 5 is less than 0. Collect like terms, we are going to see that this is going to be x minus 3x, which is minus 2x. Okay, if did we actually take this properly? Okay, let's see. That's minus 2x in this case. Then minus 2 plus 15, which is a 13. Okay, everything over x minus 5 is less than a 0. Okay, so this is what you're going to do. We have got a fraction in this case. It's best for you to use the table now to find the actual values of x from this inequality that we got. So this is what you're going to do. From our table, we have got the solutions that we obtain from the values of x. Okay, we are going to find the critical values of x from the fraction that we obtained. Okay, so I also want you guys to just cross-check again and see if everything is fine. Let's say x minus 2, x minus 5, minus 3, okay, x minus 5. That's 1 here, x minus 2. Okay, x minus 5, minus 3, x minus 2, minus 3x, 15. Then we have got minus 2x, and 13. Okay, so let's find the critical values. Everything is fine, or you just have to cross-check again. So the critical values, you're going to equate the numerator to 0, then you find the value of x. Minus 2x plus 13 equal to 0. That's minus 2x is equal to minus 13. Divide by -2. By -2. So our x is going to be 6.5. That's 6.5. We find another one, x minus 5 must be equal to 0. So x is equal to what? X is equal to 5. So on the table, this is what you're going to have. Our values of x, they are supposed to be taken from 5 and 6.5. So we just take that idea of a number line to say, let's say your 5 is at this point, your 6.5 is at this point. We can have solutions which is less than -5. We can have solutions which are less than -5. We can have solutions in between 5 and 6.5. We can have a solution where x is greater than 5, but less than 6.5. We can have solutions which are above 6.5, that is solutions greater than 6.5. So this is the idea that you take on the table that you are going to draw. So your table, you are going to have it this way. So we can just draw a smaller table here. All right, so that's it. 1, 2, 3. Okay, this table is ugly, guys. Okay, let's just make it somewhere like this. All right, so this is what we are going to have for the solutions first. We have got x here, which is less than 5. So we've got x less than 5. Then we've got 5 less than x less than 6.5. Then we've got x, which is greater than 6.5. These are the ones that you write here. Then you write the critical values one by one. You start with the numerator. These are the critical from the fraction. We had minus 2x. So these are the ones that you're going to write on this side, all right, like this. So we got negative 2x plus 3. And on this one, we have got x minus 5, okay? On the other hand, what do we have on the other hand? On the other hand, we have got the solution, this whole fraction as it is the resultant. So we are going to take the resultant as it is, which is negative 2x plus 13 over x minus 5. So this is where we are going to have our solutions. So we want a combination of values that when we are to substitute the values of x into the resultant, this resultant here, it must correspond with what is given on the inequality. The inequality is saying the resultant is less than 0. That's our resultant must be a negative. So this is what you're going to do. You insert your values when x is less than 5. You just think of any value of your choice. Any value less than 5, we can say 4, okay? We can take our x here to be 4. Any value less than 5. You substitute here when x is 4, you substitute here when x is 4. All right, so let me just share the whole screen so that we can just put the calculator here. All right, so let me just show the whole screen. I hope we can see the calculator now. All right, so this is what I'm going to do. So that's negative 2 times x being 4. So that's negative 2 times 4. Negative 2 times 4, then plus 3, okay? Which is going to be minus 5. So that's a negative here. Minus, we consider the sign, it's a negative. So here we are obtaining a negative. When x is 4, you substitute here, it's 4 minus 5. 4 minus 5, guys, that's a negative. So now you are on the combination now. This combination, it's a division. So these two are dividing. You are dividing negative divide by negative. So negative divided by negative gives you a plus on the resultant. So as you can see, a plus is wrong because our answer is supposed to be a negative. So this is actually wrong. We do not need this answer. We move on to a number between 5 and 6.5. 5 and 6.5, we can even take 6. 6 is in between 5 and 6.5. So when x is equal to 6, I'm going to use when x is equal to 6. Let's substitute into onto our calculator here. Okay, that's minus 2x, that's minus 2 times x, which is 6 plus 3. Okay, we are obtaining a negative. So here we are obtaining a negative. When x is 6, we substitute here 6 on x. It's 6 minus 5, which is 1. 1 is a positive. So we are obtaining a positive. Negative divided to positive gives us a negative, which is the one that we actually need here. So this is where our answer is going to lie. We move on to values which are greater than 6.5. We can try even one value, maybe 7. We substitute 7, just like what we did. That's 7 here. So let's just substitute a 7. That's a negative 11, which is a negative, okay? When x is 7, we substitute here 7. 7 minus 5. So 7 minus 5, that's 2, which is a positive. So we are going to see it is going to be a negative. Negative divided by a positive, it's a negative. So we also need this answer. So our answer is going to lie where it corresponds with the sign which is less than. And we saw that it corresponds with the sign at this point where we've got -1. And this is taken from this combination or from these values of x, where we saw that our x was greater than 5, less than 6.5. Also, our x here was taken, which is a negative, is from x, which is greater than 6.5. So you're now combining the given solution. So these are the values of x, or these are the solutions that you are going to obtain for x. So it's not like always you are going to obtain 2 combinations. Sometimes it might be 1, maybe x is, so we just have to check with the question that we are given if it gives us exactly what we have here as the solution. So let me just have another example that we are going to use still on these fractions, on rational fractions. Let's say, okay, the second question on rational fractions, let's say we are given 2x minus 1 over 2 plus x, which is less than 1, like this. Okay, so remember what I said. The first thing, bring all the functions on one side and never cross multiply. So in this case, we are going to bring the 1 to the left-hand side is going to be negative. So it's 2x minus 1 over 2 plus x minus 1 is less than 0. Then from there, you can add the given, or you can subtract the given fractions by taking the LCM, which is 2 plus x, or x plus 2. So this you can even write as x plus 2, guys, not to confuse yourself. All right. So x plus 2 divided by x plus 2 here, that's a 1. So 1 is going to multiply 2x minus 1. Minus, you do the same. This is same as over 1. So if you divide, it's going to be x plus 2. So it's minus 1 into x plus 2, which is less than 0 here. Expand the brackets. That's 2x, 1 by 2x, which is positive 2x. Then 1 times -1, which is -1. -1 times x, that's negative x. -1 times 2, which is -2. Everything over x plus 2 less than 0, like this. All right, we move on. We have to combine until we have got a single fraction, 2x minus x, which is x, minus 2 minus 1, that's -3 over x plus 2 less than 0. So like I said from the previous question, that what you need at this point is to find the critical values from the numerator and from the denominator. So you're going to equate the numerator to 0. So x minus 3 is equal to 0. So x becomes a 3. Or on the other side, x plus 2 is equal to 0. So x becomes a -2. So these are the critical values, or the values of x at the critical points. So now to find the exact values, solutions, we just need to understand how these numbers are represented on the number line. So we know that this is where we are going to have -2. Let's say we've got a 0 here. That's -2 and 3. So from these values, the critical values, we can see that we can have a solution. So here we are just taking all the possible solutions that we can have. So the possible solutions can be values which are less than 0 at this side. These values that are less than -2. So that's x is less than -2. Then in between -2 and 3, we've got values in between. That's x is greater than -2 but less than 3. Then we've got values which are above 3 or greater than 3. So that's x is greater than 3. So now with these solutions, we represent our table. Remember what I told you guys about the table. We are going to have the inequalities, that the possible inequalities are the ones that we start with. So we are going to start with our possible inequalities. then the solutions that we have from this fraction, then the resultant at the end. I hope we saw that one. So we're just going to redo this part. All right, so that's okay. So let's indicate the first one. We had x, which is less than 2. So that's x here, or even we can just write it on top here, or even here, no problem. X is less than -2. Then we have got -2 up to 3. Then we've got x, which is greater than 3. Okay, so these are the possible solutions that we can have. So from our possible solutions, let's start with x minus 3. We've got x minus 3 here. All right, so let's just use this one. We've got x minus 3, x plus 2. Then the resultant as it is, which is x minus 3 over x plus 2. All right, so this is where we are going to find our final answer now by substituting the values of x, which lie in the given interval, the intervals that we have in this case. And the intervals are the ones that we have written here on top. So these are the ones that we are going to refer to. So the first one is at a condition where x is less than -2. So when x is less than -2, just pick any value of your choice. We can choose -3. So if we substitute -3 here in place of x, that's -3 minus 3, which is -6. And -6 is a negative, so it's going to be a negative. We substitute -3 here, -3 plus 2, that's -1, which is a negative. So what is the resultant sign that you're going to have? We are dividing this fraction. So we're going to divide negative, divide by negative, which is a positive. All right, we move on to values in between -2 and 3. So you can just pick any value of your choice. In this case, I can even pick a 0. It's in between. Take note, from -2 up to 3, 0 is in between. So when x is a 0 here, that's 0 minus 3, which is a -3. That's a negative. 0 plus 2, that's a positive, which is 2. So it's going to be a positive. And we divide the numerator and the denominator, that's plus, divide by a minus, which is a minus. We do the same when x is greater than 4. We can just pick, when x is greater than 3, we can pick 4. That's 4 minus 3, which is 1, which is a positive. Then here we've got 4 plus 2, which is 6. That's a positive. So we now back to division, positive by positive, that's a positive. Now let's analyze what we are supposed to have as our solution. Our solution is supposed to be the whole fraction here, it's less than 0. Being less than 0, it means we are referring to negative values. So we need a solution which is a negative, and a negative, we can only see that on the resultant. The resultant is taken from this resultant where you are dividing the fractions. The only negative that we have is taken from here, where the solutions are from the above part here, where x is greater than, so therefore our x here is greater than -2, but less than 3. So these are the values of x that we are going to obtain in this case. So be very, very careful with these typical questions that you'll be given to solve for the inequalities. The first thing that you need to know or to understand is that every solution that you're going to take to have is from the critical values. From the critical values, you can have a table, you can have a graph. So like I said, we are going to work with more questions, revisions from past exam papers that can actually help us to understand more about this topic. Okay, let's look at this other part, which is the modulus. Okay, now you are given the modulus. If you are given the modulus, this part you can work it from our functions. I'm going to explain another topic on functions where we've got the modulus of a function, but here we are dealing with the modulus under inequalities. Okay, so the first thing, or the first part, or the first type of a question that you'll be given is where you are given the modulus on one side. Okay, so given the modulus is like this, guys. Okay, so given modulus on one side, Okay, let's say we are given this format. This is the format that you are supposed to maintain. Whenever you are given this part, you are supposed to maintain this format. Okay, so if we are given the modulus of x is less than a, like this, it means, okay, so this part means that then our x is greater than negative a, but less than a. All right. What does this part mean, guys? We have got two possible values of x that we have from a, which can be a positive or which can be a negative. So that's what you are simply introducing into the function. All right, so let me explain if we are given this as an example. Let's just take an example that we are going to use for the modulus function. Remember, I told you, whenever you've got a modulus, then you can write in this format that I indicated there. Okay, so let's take, for an example, this question. We are being asked to solve for x, given the modulus of 2x minus 5 like this, okay, is less than 3. All right, so what are we supposed to do in this case? This part of modulus, which is the modulus of 2x minus 5, is the one that is represented by the modulus of x. We saw that it was going to be x is greater than a. So our x is the whole of this part under this part, the 2x minus 5, is representing the x. So this is what you're going to substitute in place of x. So we are going to have this as 2x minus 5 is greater than minus a. Our a in this case is 3. So it is going to be minus 3, but less than positive 3. So you're now back to your O-level mathematics now. Remember, guys, on your O-level mathematics, we had inequalities of this nature, where I told you guys that all you need is to simply divide this into two inequalities. You separate from the middle part here, which means you're going to have two inequalities. The first one of negative 3 less than 2x minus 5, or another one starting with 2x minus 5 in the middle part, but less than 3. Then you solve as usual. Okay, so you can transpose negative 5, which is going to be positive 5. So it's negative 3 plus 5, which is 2. All right, so you're going to obtain 2 less than 2x. Divide by 2 by 2. So our x there is going to be, all right, so you're dividing here. So our x is going to be greater than a 1. All right, we move on to this side. We do the same transpose negative 5, which is going to be positive 5. So 2x is less than 3 plus 5, which is 8. We divide by 2 by 2. So x is going to be less than 4. So in this case, there is no need for you to refer back now to the table or to the graphical method. There's nothing like that. On this one, we just have to combine the two inequalities. We are given that our x here, the first x is greater than 1, but less than 4. Remember, how do you combine, guys, from your O-level maths, where you are given this format of writing x in the form of, okay, let me just change here, of writing our x in the form of x is greater than a, but less than b, where a and b are constant. So this is what we have. X is greater than 1, so x is greater than 1. The same x that we are talking about here is less than 4, so x is less than 4. So these are the possible values of x that we have. X which is greater than 1 but less than 4. So please make sure that if you are given the modulus on one side, then get back to this formatting that I indicated here. This is the format that you use from this presentation that you have here. Then make sure that you have to rewrite your inequality in this form. Then your answers shall be taken from this calculation that you're going to do or that you're going to make. All right, so let's see if we have got now modulus on both sides, okay? Because that one was on one side. So let's just see here. Okay, let's have this. So you're gonna have modulus on both sides. So that's modulus on both sides. All right, so this time you are given a consideration, guys, where you have got the modulus, maybe it's x plus a here, then on the other side is x plus b. I don't know which form I will be given. So that, but you'll be having the modulus both sides. You can work with the graphical method. The one that I said is best for us to work with it if we are done with the graphs. So that one, I'm going to explain it from the graphs. And there's no way we have to explain that one. So no, we are going to see that one later on. Anyways, these are the stages when that you're supposed to do. When given modulus on both sides, you are supposed to square both sides and solve as usual. So the first thing is to square both sides and solve as usual. So you have to square both sides, all right, and solve as usual. All right, so what am I trying to say here? You'll be given an inequality. For example, in this case, we have got the modulus of 3 minus 2x like this, which is less than the modulus of x plus 2 like this. All right. So what you're going to do is to take these as functions, you square them. So you're going to square 3 minus 2x. So that's 3 minus 2x squared is less than x plus 2. You also square this. Okay. So these ones you can expand, guys, from your maths or from your O-level maths. You know how to expand these two brackets, or you can even use the identities. A plus b squared is equal to a squared plus 2ab plus b squared. So that means in this case, if we have to expand the brackets, we are going to have 9 minus 12x. So if you multiply, that's 3 times 2, which is 6, negative 6 times 2, which is negative 12. So that's negative 12x. Then negative 4 squared, negative 2x squared, which is going to be positive 4x squared. All right, we do the same thing here. That's less than x squared. So it's going to be x squared plus 2 times 2, which is 4x, plus 2 squared, which is 4. So I'm just using this identity. Or like I said, please, if you do not understand this, expand your brackets properly the way that you know. 2 brackets, 3 minus 2x, 3 minus 2x, you expand. You do the same thing on x plus 2 squared, x plus 2 into x plus 2, you expand as usual. You're going to obtain the same answers as the one that we have here. Then from there, like I said, after you have squared the two sides, then you're supposed to solve as usual. Then that means here we can transpose x squared to the left-hand side. That's 4 minus x squared, which is 3x squared. Okay, we've got negative 12. 4 to this side is a negative, so that's negative 16x. Then we are remaining with 9 and 4. 4 to this side is a minus, so 9 minus 4, which is a 5, is less than 0. So this is what you're going to have. 3x squared minus 16x plus 15. Okay, so what are you going to do, guys? We are supposed to solve, like I said, you solve the normal way. I don't know, you're going to find the critical values. After that, you use a table, you use the graphical method. It's now up to you, but in this case, we need the critical values. Okay, so let's try and find the critical values. We are going to multiply the first term. Remember your factorization, guys. 3 times 5, that's 15. 15x squared. We have factors of 15x squared, but if we add these, we must obtain the middle term, which is negative 16. Yes, so we've got negative 15 x and negative x. If we multiply, that's a positive 15. If we add, that's a negative 16. So you're going to substitute this into the middle term. That would be 3x squared minus 15x minus x plus 5 is less than a 0. 3x is common. Remember, by grouping into 2, we can see that 3x is common. So we can factor out 3x. That's 3x squared divided by 3x, which is x, minus 15 divided by 3, which is 5. Then here, to obtain x minus 5, factor out negative 1. That's x minus 5 here is less than 0. So this one is just a repetition, guys, from your O-level maths. That's why I'm rushing here. So we just need the critical values. All right. So now from this part, 2 brackets are the same. We've got x minus 5, x minus 5. So we're going to have x minus 5 here. 3x minus 1 is less than a 0. Therefore, we can have the critical values from this point of x minus 5 equal to 0, where x is going to give us a 5. So x is going to be a 5. From 3x minus 1 is equal to 0, x is going to give us 1 over 3. So these are the critical values that you're supposed to indicate from this point, where x is equal to 5 or x is equivalent to 1 over 3. So like I said, it's either you're going to take it from the graphical method or from the table. All right, from the graphical method, we need a condition where our f of x, in this case, as you can see, our f of x is given as 3x squared minus 16x plus 5. I told you that if a is a positive like this, then it's going to be a smiley shape like this one. So we are going to have our solutions. As you can see, all the solutions are positive. Here it's 5, it's a positive, a third is a positive. So which means we are going to have our solutions from one side of the graph like this, all right? So that's our y and x here. So we have got our solutions on one side of the graph. So it's going to be somewhere of this nature like this. All right. So this is what you're going to have from our graph here. All right, where x is a third and the other one, which is a 5. So in this case, the values of x that we have, that's a third here, the smaller one, which is a positive, a third. So we've got a third here. And another one, which is a 5 at this point here. That's where we're going to have another point. Okay, so remember what I told you guys. If it is given that your f of x here is the one that you work with, so our f of x, the whole of this function, we can see that it's less than 0. So where do we have the values of x where our function is less than 0? Our function is less than 0 below the x-axis. So we need the values which are below the x-axis, and these are the values in between this region. That's where we've got our values below the x-axis from 1/3 to 5. So which means we can write this as, therefore, our values of x is going to be greater than 1/3. But the same values of x that we have will be less than 5. So that is if you are using the graphical method. So I want to challenge you guys to do the same question, or from these critical values that we have, I want you now to work with the table. Remember, I told you about the table. You represent on the table, you find your final values. So on the table, let me just show you what it's going to look like. Remember, we got our critical values here, which is a third. We got our critical values here, which is a third and 5. So you can know that from our number line, definitely, that's where we've got our third here. All right, we've got a third and we've got a 5 here. So the values that we expect are the values which are less than a third, okay? Or the values which are greater than a third, but less than or 5, or the values which are greater than 5 on that side. So which means on your table, these are the values that we are supposed to have on your solutions. We are going to have something like this. I'm just showing you what you're supposed to have. So I want you to proceed with that one. I'm not going to finish everything, but I want you to try. X is less than a third. X is greater than a third, but less than 5. X, which is greater than 5. Then the brackets now from the solutions, these are the ones that you're going to take. So you're going to have here x minus 5, all right? You move on to this one, 3x minus 1, all right? Then the last one will be for the product of the two. They are multiplying each other. So it's x minus 5 like this. So it's going to be x minus 5 into 3x minus 1. So you put in the solutions that you have, the values of x in within, then you can obtain your answers now from the resultant. So you're going to see that your answers will lie in this region. That's where we are going to have your answer here, where it is going to give you an x. So I want you to try. If you have a challenge, let us know, guys, on the comment section so that we can be able to revise another way, in any other way that we can. Okay, so I want you to try also these questions so that we are going to meet again in another class, now working with question papers, and we're using other methods. Remember here, I was just limiting to something else, but on our next platform, we have in question papers, we shall be explaining other questions. So these are actually from exam past papers. So these are exam past papers. So I just want you to work out these ones. I just want to give you a few. There are a lot of them, but I'm just going to give you a few for now. Then we work with others when we meet in another class. So that's our first question here. All right. Then the second one, I'm just picking one or two. I'm not picking everything. I'm just picking the ones that I think they can help us. All right. So you try them, any challenge, let us know, guys, on the comment section. Try the questions. Then when we meet in our next class, I want you to be understanding these topics, these questions, sorry. All right, then, okay, let me just add on the modulus. Do you have anything there? Or the modulus, I'll actually explain it when we meet, when we have that final class. That one I'm going to explain. So you're going to try also this one. x minus 1 over x plus 1 is greater than 0. Then 5, let's just make them 6. Okay, 2 over x minus 3 is greater than 3 over x minus 2. Then the last one, I want you to try 2x squared over x plus 1 is greater than x. All right, so that's it, guys, from Maison African Motives on A-level mathematics. Till we meet again.